ओके नाउ लेट्स टेक अप। आपको ये चीज़ सारा समझ में आ गया या हमें फिर से करना है इसमें कुछ?
यस सर समझ गए।
चलो ठीक है, फिर भी एक क्वेश्चन लिखते हैं यहाँ पे जो आप खुद ट्राई करेंगे। चलो वो हम ये डेफिनेशन करने के बाद करेंगे, ठीक है? सो लेट्स फर्स्ट राइट डाउन a definition. The definition is, let V be a finite dimensional vector space let V be a finite dimensional vector space then an ordered basis. An ordered basis of V is an ordered sequence like V1, V2, so on, Vn of vectors in V such that the set V1, V2, so on, Vn is a basis. ठीक है? तो अगर हमारे पास कोई finite dimensional vector space होगी, then we know that it has a finite basis of cardinality n if the dimension is equal to n. Then how do we define the ordered basis? This ordered basis is just an ordered sequence of vectors such that v1, v2, vn is a basis. So by the term introducing ordered, it means that we will treat this v1 as the first element of the set. Usually जो sets में elements होते हैं, they do not have any proper order. They can be written in any way. हम v1 को कहीं पे भी जगह लिख सकते हैं, v2 को किसी भी जगह पे लिख सकते हैं. In a set, the position of an element does not matter. It should just be an element. तो वो फिर पहला element होगा या last element होगा या कहीं पे भी होगा, it doesn't matter in a set. But now here we are introducing the notion of order. So once we write an ordered basis, तो हमें इस basis में फिर पहला जो vector होगा, we will have to assume that as the first element of this set. And then similarly, this V2 is the second element of the set. And similarly, Vn is the nth element of a set. ठीक है? These ordered bases are also known as the coordinate basis. Ordered basis is also known as coordinate basis. तो ordered basis को हम coordinate basis भी कहते हैं. So before I also told you that what is the reason that why we call some base as an ordered basis. It is just to refer that it is just for the thing that we can refer to the first basis vector, or we can refer to the second basis vector, and then we can call some vector as a third basis vector and so on. Because usually in a set, actually a set is an unordered sequence of elements. So set में we cannot refer to some element as the first element, and we cannot refer to some element as a second element and so on. Actually in a set, everything is jumbled together and they are just the plain elements. ठीक है? But in an ordered basis, some vector is referred to as the first vector, some vector is referred to as a second vector and so on. So now let beta is equal to v1, v2, so on, vn be the ordered basis of v. be the ordered basis of a vector space, be the ordered basis of a vector space V, and let V belong to V. So we are choosing V is some vector in V. Then V has a unique representation. This we have already done. Then V has a unique representation of the form V is equal to some, suppose alpha 1 V1 alpha 2 V2 plus so on alpha n Vn. तो हम अब ordered basis choose करेंगे. Then under any basis we know that whenever we choose a vector V from V, then this V can always be written as a linear combination of the vectors from the basis with some scalars from the scalar field. So where this alpha 1, alpha 2, so on, alpha n are scalars or just scalars. We know that they are the scalars from the field over which V is a vector space. Now, as we have introduced the notion of an ordered basis, now these coefficients, the set of these coefficients or the sequence of these coefficients, because now since we have an ordered basis and we have defined the ordered basis as a sequence, so sequence में जो terms होती है, there is a first term, there is a second term, there is a third term, and so on. Now, since we have this V as this linear combination with respect to this ordered basis, so therefore this alpha 1 will be called as a first coefficient. This will be the second coefficient. Alpha n will be the nth coefficient. So therefore, there is a sequence of these coefficients. So now these coefficients will be arranged in some particular order, and that order depends on the order of the vectors in this basis. So if therefore this Vn is the V1 is the first vector in the basis, then alpha 1 is the first coordinate vector because we have the coordinate basis. V2 is the second vector in the basis. Alpha 2 is the second coordinate vector. And similarly, Vn is the nth vector in the basis. So therefore, we call this alpha n as the nth coordinate in this representation of V as a linear combination of the basis beta. So then actually now introduce the notion of this ordered basis. We can call these vectors as the scalars. The scalars alpha 1, alpha 2, so on can be now referred to as the coordinates or referred to as the coordinates they are referred to as the coordinates of V with respect to the basis beta. तो हमने यहाँ पे basis beta choose की. Then with respect to this beta, we can write any vector V as this kind of a linear combination. Then these coefficients, alpha 1, alpha 2, alpha n, which are the scalars, these scalars are now referred to as the coordinates of V with respect to the basis beta, And we define the coordinate vector. And define the coordinate vector of V relative to beta. Now you have to remember what are these terms relative to beta, which is denoted by इस तरह से. This is V. This is the notation for the coordinate vector of V relative to the basis beta. So this is the notation, coordinate vector of V related to the basis beta, and this is defined by this V coordinate vector of V related to the basis beta. This is a column vector of the scalars alpha 1, alpha 2, so on alpha n. ठीक है, तो इस तरह से अगर हमारे पास कोई भी वेक्टर होगा from the vector space V and we have an ordered basis beta, then we can always express this V as alpha 1 V1 plus alpha 2 V2 plus alpha n Vn. Then we form a column vector of alpha 1, alpha 2, alpha n by writing first element as alpha 1, the second column is alpha 2, the nth column is alpha n. Then that column vector is called the coordinate vector of V related to the basis beta. Okay. So in fact, if we change the basis, this coordinate vector will be changed. In fact, अगर हमारे पास यही basis beta होगी और हम इसमें vectors का order change करेंगे, then we will get a different column vector. तो इसमें ये vectors change हो जाएंगे, इसमें scalars ऊपर नीचे आ जाएंगे. So therefore, with respect to different bases, we can find the different coordinate vectors. So now here the nice term is that we have to now use more frequently this coordinate vector of a vector V related to the basis beta. It is defined as, it is first denoted by this V beta and is defined as a coordinate and is defined as a column vector whose columns are the coefficients of Vi's when we express this V as a linear combination of the vectors from the ordered basis beta. Now, before going into more details, actually now we are on a way to define the matrix representation of a linear transformation. तो उस चीज के लिए हमें इन basic चीजों की जरूरत है. So first we must be more acquainted with the notations that we are going to use there. So better we will do it slightly, because then we will have to always use it as how we express a linear transformation in the form of a matrix. The first step is that we will define this coordinate vector of any vector V related to some ordered basis beta. Now, before going further, we shall take certain examples. So let's take an example. So example define करने के लिए हम we will take some vector and then we will define some ordered basis and then find out this coordinate vector of that particular vector with respect to the chosen ordered basis. Example. So consider the vector space. Consider the vector space, suppose P2 of R. ठीक है? And let suppose V is equal to, we have to choose this V as a vector of P2 of R. तो अब बताइए कोई polynomial which is in P2 of R. हाँ, कोई और इसकी आवाज नहीं आ रही थी. बताइए जल्दी, मैं खुद भी लिख सकता हूँ लेकिन आप बताइए कोई
1 + x².
थोड़ा सा डिफरेंट बताइए, इतना आसान नहीं चलेगा. माइनस प्लस कुछ भी. हाँ सीआर, आपका रोल नंबर क्या है? 44. चलिए 44 हम पहली टर्म लिखते हैं, देन प्लस बताइए कोई और नंबर.
25.
चलिए 25x, देन माइनस चलिए 17x². ठीक है, हम कुछ भी लिख सकते हैं. We just need any polynomial from P2 of R. Now we will choose a basis and let beta is equal to, पहले हम choose करेंगे आसान सी basis which is the standard basis, and let beta is equal to this. Then we will express this V as a linear combination of these vectors over the scalars from R. Then we can write then v is equal to, this is 44 times 1 plus 25 times x plus, sorry, plus minus times 17 times minus 17 times x square. अब जो यहाँ पे ये 1 हमने लिखा, this is a 1 which is in the basis. This x is a vector here, and this x square is a vector in the basis. So what is the coordinate vector of v with respect to the basis beta now?
44, 25.
25 minus 17.
The coordinate vector of v relative to the basis beta, this is equal to the column vector 44,
44,
25 minus 7.
25 minus 70.
चलो ठीक है, आज इतना ही करेंगे हम, ठीक है?
Okay, sir.
Yes, sir.
Okay, sir.